So when we take the idea that if we treat all gases as ideal, then 6.02 times 10^23 molecules of any gas behaves like 6.02 times 10^23 molecules of any gas. That's Avogadro's law. And if we take Boyle's law and put Charles' law together, then we can solve for that K, and we get the ideal gas law, which is pretty great. Anyway, so it's the ideal gas law. So whereas P, V, and T, the combined gas law, tells us compares two samples of gas. These are the pressure, volume, and temperature of one condition, and the pressure, volume, temperature in another condition. The combined law tells us about a single gas in a single condition. So let me just turn so the combined law, we had P V over T was a constant. Well, now we know what that constant is. That constant, K, is moles times a gas constant that we're going to label R.
Wait.
Yes.
Does pressure have to be in atmospheres?
Yes. So if we are using pressure in atmospheres and volume in liters, then the R value is 0.0821. Keep forgetting if I made a poster for this yet. Yeah, there it is. So here's the kinetic molecular theory. R is right up there, 0.0821 liter atmosphere per mole Kelvin. Right there.
And that's for every single.
Every exercise in this class is going to use atmospheres, so R is always going to be that.
We're going to some other pressure I have to put in the atmosphere.
Yes. But when you do the math, it'll be in. Okay, does everybody hear that? Yes, if I'm ever going to give you another pressure, you need to turn it into atmospheres. Yes. When you do any kind of math, combined law or Pivnert, ideal gas law, your pressure needs to be in atmospheres. So if you get it in some inches of mercury or millimeters of mercury, turn it into atmospheres. All right, so that's it. So pressure is going to be in atmospheres. V is going to be in liters. N is number of moles. Remember gram per mole? Yep. You can turn gram into mole, but only for gases. R is the gas constant. T is temperature. And again, if you are using liters and atmospheres, the gas constant is 0.0821. It's a special gas constant just for lazy chemists.
Wait.
It's not the standard unit gas constant. Yes?
Should we write down the if it's in pascals also?
No. We only use this in AP Chem.
Yeah.
Because in AP Chem we have to use the standard units. So, and even then, not very often. But yeah, so since we're always going to be using atmospheres, our R is always going to be 0.080. Pretty simple. So what does it allow us to do? Well, if it allows us to answer this question. If I have this sample of gas at this pressure and this temperature, how many moles of gas do I have? Or if I create this many moles of gas at this temperature and this pressure, what volume will it occupy? Next week, we're going to do some labs. We're going to do a bunch of labs that does exactly that. We're going to create a certain amount of moles of gas at a certain pressure and a certain temperature, and we're going to measure the volume that it's going to create. Then we're going to blow it up. Okay, so any questions before we do some exercises together?
No, sir. Let's try it.
Let's do it. Let's light this candle. All right. What volume does 3.45 moles of helium occupy at 1.29 atmospheres and 26.9 degrees Celsius? So let's rewrite this into Pivnert. Pivnert. PV equals nRT. No joke. One of my mentors had this on his license plate. It's like, you know you're a big chemistry nerd when you have Pivnert on your license plate.
Yeah.
And he made sure he got a new license plate every year. So behind his desk, he had like 6 of them. Just, cool. All right, whatever. You want to spend the money? Neat. Anyway, so the pressure. What am I going to put in for pressure for P? 1.29 atmospheres. And what am I going to put in for volume? V. That's what what I'm solving for. And what am I going to put in for n? 3.45. And what am I going to put in for r?
0.018.
0.821. And what am I going to put in for t?
299.9.
Yeah, 299.9. I don't know why I wrote it that way, but here we are. Anyway, so doing this, solve for the volume. This pen eventually gets dark. Come on, pen, get dark. You're lighter than old pen. Old pen is better. Nope.
It pulled.
I also got 65.8.
Okay, I'll take it.
Somehow I got that.
And the unit is meters. Okay,
I
so
actually got 65.8.
it really is that simple. So in this class, you'll be given 3 of the 4 variables most of the time. Most of the time. But there is a really cool thing you can do with Fibner. So it certainly is. Well done. Okay, this one's for you. Then I'll show you that really cool thing that's different you can do with Fibner. But solve that one first.
Okay. What did you say was?
Pulled out.
No. You think you're so damn funny?
So T was actually equal to. You wanted it Celsius.
Dankness overload.
No.
It's gonna stay.
Boy, that's
Ring, ring, ring. Julian's calling. Boy, what a that is.
Okay, so what did you get for the temperature? First, what did your calculator kick back in Kelvin? How much?
I got 208.4.
208
Yes.
Kelvin?
I think so.
Okay. Okay. Anybody else get that too?
Yeah.
Okay, there's like 20 of you, so
I would hope someone. That's dang.
110 atmospheres, 12.6 liters, 0.810 moles, 0.082.
I got 208.
And okay, so 208 Kelvin. And then how do we turn a Kelvin into a Celsius? Yeah, subtract 273. So we're going to take this and we're going to subtract 273, and it's going to kick out negative 65 degrees Celsius. Does that sound about right?
Yeah.
Okay. If you are comfortable with this whole Pivner thing, give me a thumbs up. If you have any questions, wave your hand around. We're happy with this?
I am.
All right. Okay, this is the nifty trick that you can actually do. You can identify a molar mass. Now again, a molar mass is a gram per mole on the periodic table. And if you have an unknown gas, and you identify that unknown gas by its molar mass, then you can know exactly what gas we're talking about. So what is the molar mass and identity of an unknown gas if 1.84 grams occupies 1.15 liters at 1.05 atmospheres and 320 Kelvin. So you need two pieces of information for molar mass. You need gram and you need mole. The gram is given to us in the exercise. How are you going to get mole?
The molar mass conversion people do.
No,
Pivnert.
Pivnert. Yeah. You're going to get moles from Pivnert and you're going to get the grams from the exercise, and that will give you a molar mass, which then will allow you to identify what the unknown gas be. Give it a try.
And the R is the mole.
R is the gas constant.
N is the mole. N is
You're solving for it. Yep, you're solving for the N.
Wait, what is it? Point oh.
So,
1.05.
do we keep Kelvin as Kelvin or do
Yeah, you can leave the Kelvin as Kelvin.
It's
Somebody
funny.
Are you guys being an active participant in your education back there?
Yeah.
Remember, if you're not paying attention during practice work, you forfeit your ability to ask me questions later on.
Wait, we need to convert Kelvin to
No. Anytime you do any kind of math or maturity, it's going to be in Kelvin.
I ought to be the brakes on you. Why I ought. I gotta do something though.
Well, it's going to be a tiny number.
Okay.
Because it's not going to give you the mole that matches anything on the periodic table until you divide it into mass. Remember, molar mass is grams per mole.
So I do those grams divided by the tiny number as well.
Yes.
It's like that, right?
Okay, I did it.
I'll let everybody else catch up with you. So look.
Wait, did you get
And 50.
Now you look on the periodic table and figure out what it is.
Wait, I got 40.03.
It's
Argon.
probably gonna be
Argon.
No, because that's not 40.03.
Oh, because it's a gas.
Close.
It's close enough.
That's close enough.
Yeah, rounding issues. Okay, so just so we're all on the same page, when you did Pivnert, what was the number of moles you got?
0.0459614.
0.0459?
Yeah.
Okay, so that's going to give us Pivnert, or the Pivnert's going to give us the moles. We're going to divide it by the mass of the gas that is provided, and what we're going to get is a gram per mole. And this looks like it's going to be, you said it was 40 point something?
Yeah, it's 40. I got 40.
Sure, 40.0 grams per mole. And of course, 0.3, whatever. And then you look at the periodic table, and the only gas that has that mass
It's
is argon. A colorless, odorless gas that you could not identify by just looking at it. You would have to weigh it. That's what we did. We weighed the gas. Weighing the gas is actually not nearly as hard as you might think it would be.
Is there argon in this room right now?
There is.
A lot of it?
About 1/2 of the air in this room is argon.
Was argon like poisonous?
What
Nope.
did I get? 40?
Doesn't really do anything.
Big percentages?
Okay. How are you feeling about this?
Great. It's really easy.
Okay, that's
No, I don't want to do that anymore.
more of the same. More of the same.
Are you ready for work come out?
Yeah. I'll leave these up there if you want to do them. Otherwise, you can work on your own.
Mr. Rogers,
Yes.
what was that formula yesterday? The thing times the thing divided by the thing.
The combined law?
Oh, it's
EV over T.
Yeah. So the combined law is
I didn't write it down.
P over PV over T equals a constant, which means P1 P1 over T1.
Okay, I just didn't write it down. I forgot to write it down.
Is it pretty obvious?
Yes.
What are you doing? Are you trying to figure out if they can?
Don't know how to spell my name still.
Bye, thank you, people.
Let's see.